it. It's just in case. Okay, we're recording.
Yes, please, with the video.
Oh
my God.
Okay, I'm sorry. It felt good to be back at the board, guys. All right, here we go.
Just with me and time, my relationship with time is not the best thing.
Okay, that's fine. I'm a person who will be late to the day I die, so it's all right. All right, here we go. So look at problem number 1. This is where I think it's going to get a little bit, I'm going to have to use the board and keep flipping back and forth. All right, so example 1 says, finding the distance from the origin to a point on the graph. So they want, let P be a point xy. It's a point on the graph of y equals x squared. They gave you a picture right here. Here's point P. It's a point on the graph of this parabola, y equals x squared minus 1. The main thing they want us to do in this problem, guys, is they want us to express the distance d from point P to the origin as a function of x. So they want us to, right here, the distance from P to O. They want us to express the distance in between those 2 points as a function of x. All right, so let's do this. So the first thing I would do, don't worry about the other parts, let's do part A. So I think I'm going to have to do this, which is where it's going to get annoying. Let me get some board space. All right, so everybody has the problem in front of them. It says our job is to express the distance from P to O as a function of x. That's our job. That's what we're going to try to do. Well, guys, we need to establish a go-to get-started formula. What would be your go-to get-started formula to find the distance in between 2 points on that slanted line? Anybody know? What would you use to find the distance in between those 2 points? The distance formula. So that's our go-to get-started formula. So let's set it up. The distance in between P and O would be the distance formula. Let's do it, guys. So it was the point xy to 0, 0, right? If everybody can look on your paper, you're trying to find the distance in between xy and 0, 0. So that would be, the distance would be x minus 0 squared, right? Can I do this at home? Am I just wasting my time trying to show you guys? Right? Yes, I am. I can't focus. All right, plus, now the distance from P to O would be y subtract 0, right? Just want to make sure I'm with everybody. Right, this point right here, it would be x subtract 0 squared, and then y subtract 0 squared. Everybody okay with that here? Yes? All right. I just get worried that I lose people. Okay, so now let's clean that up. The distance in between P and O is this. It's x squared plus y squared. Everybody good? All right, they asked us to write this distance as a function of x. So we want x to be the one going in and the distance to be the one coming out. So we really want this. That's ultimately what we want. We want the distance to be a function of x. X will go in and the distance will come out. So what you really need to do is take this problem. If x is who's going in, he can be the only variable that lives inside of this function. So that means this y, he can't be there. So we need to get y out and x in. We have to get this y value out of the problem and something in terms of x into the problem. So this is where I said you need a relationship between x and y. So look at the problem. Did they tell us any relationship between x and y? What is y equal in terms of x? Well, guys, think about it. What parabola was the point xy on? He was on the parabola y equals x squared minus 1. So if they're going to tell you that y equals x squared minus 1, that's a pre-made relationship between x and y. You already know what y is equal to in terms of x. And since that point P is a point on that distance formula and on that parabola, it's a buildable relationship. So now since we know what y is equal to in terms of x, we can plug that in and get y out. So we're going to use the relationship y equals x squared minus 1. So it's awesome when they give you a pre-made relationship. Sometimes you have to build your own relationship between x and y. So the distance as a function of x will equal the square root of x squared plus, take y out, put who he's equal to in, x squared minus 1 quantity squared. And then all we gotta do is clean that up. That's a FOIL in disguise. So either take it off of the side and FOIL, or clean it up yourself. Right, first term squared would be x to the fourth. Times them together and double it would be negative 2x squared. And then last term squared is plus 1. And then we just combine like terms.
Oh, so do you plug in the equation?
Yep, you plug in what y is equal to in terms of x. Because if we want this distance to be a function of x, x can be the only variable that lives inside of that function. So we're going to have to get y out of the equation and x in. And they told us what y was equal to in terms of x. So it's beautiful. We already had a usable relationship to get y out and more x's in. All right, let me pause. How did that feel? Is that okay? Again, I feel like the more problems you do, the better it gets. To me, it's all about establishing that go-to get started formula, and then whoever they want to be the function of, that's the only variable you want living inside of that equation. Go ahead, Michael.
Can I move the seat so I can like see the board better?
Absolutely, absolutely, Michael.
Oh,
Yeah, that's an empty seat right there. Okay? Nobody has sat there today yet, so you don't have to worry about wiping it down.
Oh, okay.
Even better. All right, everybody all right at home? Can I get a thumbs up at home? Okay? All right, here we go. Part B. Now it kind of gets easy. Once you get that, it's kind of like things just flow from here. So now it says in part B, what is D if x equals 0? So we're just going to find D of 0.
Okay.
All right? So if x equals 0, we're just basically plugging 0 in. So it's going to be the square root of, plug it right into the formula you wrote, 0 to the fourth minus 0 squared and then plus 1. That's going to be the square root of 1, which is 1. Which, guys, it makes sense. If you think about it, when x is 0, that's 0 squared minus 1. That's the point, 0, negative 1. So think about it. When you're at x is 0, how far away from the origin should you be? 1 unit. So it makes sense. The formula we wrote works. All right, look at part C. Part C says, what's the distance if x is 1? Let's plug 1 in. It's going to be the square root of 1 minus 1 is 0 plus 1. It's also 1. Because now, if x is 1, 1 squared minus 1 is 0. That puts you right here. You're at the point 1, 0. So when you're at the point 1, 0, how far away from the origin are you? 1 unit. It works. All right. All right, last one says part D. What if x is root 2 over 2? Let's plug it in and do a little math. All right, now obviously if you have a calculator, I just think of this, you can plug that in, but for me without it, you know, squared is to a power of 4, so root 2 over 2 squared would be 2 over 4, which is 1/2. 1/2 squared now is 1/4. All right, root 2 over 2 squared, that's going to be what? 2 over 4, that's 1/2, and then plus 1. 1/4 minus that is negative 1/4, plus 1 is 3/4. And then that becomes the square root of 3 over 2. So when x is root 2 over 2, that point on the parabola will be root 3 over 2 units away from the origin, is what we've just found. Okay? All right, last part is a graphing calculator part. How am I going to do that? I used to have a graphing calculator on my desktop, but it erased over the summer. All right.
Desmos,
I can't because it doesn't calculate the way the graphing calculator will calculate it, but I wish I could. All right, here we go. I'm gonna erase the board if everybody at home is okay. I hope everybody's okay, but I videoed, so I'm gonna keep that. I'm gonna get rid of this.
Oh, okay.
Okay.
I was gonna say, can you keep like the
Yep.
right side?
I'm gonna try and do a little bit on the graphing calculator so you guys can see it.
Is D the problem where it says like x equals?
D was this one, find root 2 over 2. All right, so now it says use a graphing utility to graph the function when x is greater than 0. Rounding to 2 decimal places, find the values of x for which a local minimum occurs. Yes, this gives the point on the graph where y equals x squared minus 1 is closest to the origin. So I don't know if I can do this if you guys brought your graphing calculators so you can get them out. All right. Yeah, but now you guys can't see it. Interesting. How do I do this now? How do I get you?
Project that to your screen.
But I can't. I'm not plugged in. I'm plugged in over here, and that's going to take so much time.
We can visualize.
We're going to visualize. All right. So this is so. I don't know how to do it for both of you guys. Ugh.
It's okay.
All right. We're going. All right. I'm going to walk around. I'll show you guys. All right. So guys, first thing you need to do is in y1 type in the equation that we wrote. So the square root of x to the fourth minus x squared plus 1. Hit enter.
Is there a way to like write steps? Would that help you?
I don't know, just for time saving purposes, I want to get one more example in after this one. All right, so Zoom, I'm just going to go to Zoom standard. If I go to the graph now, hold on. I don't have any graphs turned on. All right, so that's what it looks like right now when you plug it in. Okay. All right. I don't like the look of it, so I'm going to change my window. My window, it said x is greater than or equal to 0. I want to see both sides. I want to see what's going on both sides. So I'm going to leave it. I'm going to zoom my window in to, let's go real close. Let's go -3 to 3 on everything. So I changed my scales from -3 to 3 on the y. Oh, there we go. Okay. I'm going closer. So you see how it dips down there and it dips down there. Those are your local mins. You have to calculate what's the lowest spot it reaches there and what's the lowest spot it reaches there. Can you see how it dips twice? You're going to have 2 local mins. It dips twice. It's going to dip down 2 times. So you're going to find a local min at each one of these dips. All right? So to do that, you just press second, trace, and you want to go to minimum, so number 3. And you're going to do the left bound, right bound. I'm going to move my cursor to the left side of this dip, hit enter, and then I'm going to move my cursor to the right side of this dip and hit enter. And then you're going to ask it to make an educated guess. All right, yes. And you find out when x is negative 0.71, y will be 0.87. So when x is negative 0.71, y will be 0.87. Okay, so now, just to save time, not that I feel like I'm wasting it all already, the graph was like this. Oh, that's terrible. So technically, we just found out when x is negative 0.71, y will be, what do we say, 0.87. Well, guys, it's symmetric. So also when x is positive 0.871. Keep going back and forth. Okay. I can't do this. Kids at home are like getting seasick. on. My board's just blank. Oh, dear Lord.
How come that camera has like such a white face?
I don't know. Where's my board, Michael, is the better question.
You can post a picture of it later and we can move on to the next example if that's easier.
Okay, but for some reason,
Or like you can take screenshots of the car and post them on the.
oh, there it is. So guys, what I was saying is, you found out this one, it's negative 0.71, y is 0.87. Well, it has symmetry, the graph. So the other one, if you did the second trace to this minimum, would just be x is 0.71, when y is 0.87. So really the answer to that last part is plus or minus 0.71. I'm sorry that took so long. I'm not really, no idea what's going on with both groups here. All right, guys at home, sorry about that. All right, let's do it. Let's go to the next one. I gotta get my graphing calculator back up on the computer.
Would that solve the problem?
Yeah, because then I could just project that. I had a graphing calculator on my desktop, but it's erased. They erase it every summer, and we have to get it back. All right, here we go. Now we're doing problem number 2. I just don't know how far we're gonna get. We only have so many minutes.
There aren't as many letters, so.
This one we can at least get set up, which is the hardest part. All right, last one, guys. We're gonna try and get this one set up, and then we'll go from there. It says, a rectangle has one corner in quadrant 1 on the graph of y equals 25 minus x squared. So they've given you a picture to follow. Okay, another at the origin, a third on the positive y-axis, and a fourth on the positive x-axis. See figure 63. So guys, our job is to express the area of that rectangle as a function of x. So look what it said. It has one corner in quadrant 1 that's literally on the parabola y equals 25 minus x squared. It has another at the origin. It has a third on the positive y-axis, and it has the fourth corner on the positive x-axis. And there's the rectangle. It looks like a square, but they didn't call it that, so we can never assume it. That's the rectangle. We're going to try to write the area as a function of x. So guys, before we do that, let's try and label it, right? Because everybody understands, right, that the area, what's your go-to get started formula going to be? How do you find the area of a rectangle? Base times height, length times width, right? Okay, they want the area to be a function of x though. So that's what we want. We want a of x to equal the length times the width. The problem is x is who they want this to be a function of. So that means we're going to need L and W out and x is in its place. That's our goal. Okay, let's start doing that. Well, guys, what would you say the length of this rectangle is if you went from here to here on the positive x-axis? You could just say you went how many units to the right? It looks like 3, but we can't assume that. We would have to say it went x units along the positive x-axis. Does everybody agree? So the length would be x. We can get L out and x in. All right, as far as its width, I went so many units along the positive y-axis. From 0 to there would be, how many units did I go? I went positive y units. So we're getting closer. Now we have area as a function of x equal to x times y. So now I need y out and I need an x in. So we need a relationship between x and y. Did they give us one? What point on what parabola is that point xy? He's on the parabola y equals 25 minus x squared. So again, they've given you a pre-established relationship between x and y. So that's what we're going to use. We're going to use y equals 25 minus x squared to get y out and x is in. And then we're just gonna distribute to clean it up. And there it is. You have just written the area of that rectangle as a function of x. Let me pause. How did that feel?
That's the setup.
That's the setup. That's part A. Part A is done. We have written the area as a function of x. All right. Now they want the domain of it. All right. Well, the domain. Well, guys, think about where this function even started. It went all the way back to length and width, right? That's who technically lives inside of this function. Does it make sense to be working with a rectangle that has a negative length or width? No. So for domain, I definitely want the length to be greater than 0, and I want the width to be a number greater than 0. It wouldn't make sense to have negative lengths or widths. So as far as the domain is concerned, we want to keep the length and width positive. Well, who did the length really get represented by? X. Who did the width really get represented by? Y. So really, it's x that we need greater than 0, and it's y that we need greater than 0. But guys, there's even more to it. It wasn't really y. It wasn't really y who ended up living inside of that function. It was 25 minus x squared. So I really need x to be greater than 0, and I need 25 minus x squared to be greater than 0. That's your domain. X has to fit these two conditions to be the domain of this function. All right, we got to solve this. So clearly x has to be greater than 0, and I'm going to add x squared, and I'm going to get the x squared is less than 25 when I put it on the left. Is everybody okay? I added him over, and then I rearranged it. Is everybody good with that? All right. If I solve this for x, what's up?
Did you divide the negatives out?
No, I just added x squared there. And then really it was 25 is greater than x squared, but I like to read it from x squared's point of view, so I wrote x squared is less than 25. If you add this over, it's 25 is greater than x squared.
Oh, okay.
But I want to read it from x. All right, well, here's the problem. When you go to solve this, you have to take the square root of both sides. However, when you unsquare a square, you get two versions of 25. You get plus or minus, right? Can't do that. So guys, in Algebra 2, you learned that by definition, the square root of x squared is equal to the absolute value of x. It's the plus or minus version of x. So you're going to take this out and put the absolute value of x in. God, I hate this. Is less than 5. And now, x has to be, the absolute value of x has to be less than 5. Well, think about it. What numbers have a distance from 0 that's less than 5 spaces? Numbers in between -5 and 5. Do you guys remember your absolute value inequalities? If it was less than, it was an and, a sandwich. Do you guys remember that from Algebra 2? So it would be -5 is less than x is less than 5. I don't know if you guys remember that. So now you have to be these. I'm just going to finish this problem. Now, I can give you guys passes if you need them. X has to be greater than 0 and a number in between -5 and 5. Well, what numbers fit both? Who's bigger than 0 and in between -5 and 5? Only numbers from 0 to 5. And that's your overall domain. All right, I apologize that is so rushed. I did put the homework up, but it's not due. I'm going to change the due date till Wednesday night. So you guys can start working on it, but I haven't taught you everything yet. Guys on the meet, sorry about that. Have a great day. Hang out. I'll be back later for questions in the afternoon. Otherwise, I'll see you tomorrow. Guys, I'm very sorry about that. If you have any questions, reach out to me. I'll be back on in the afternoon if you want to jump on when you get home. Okay?
Trust me, it's a little more.
Thank you,
important than
Mr.
Jay.
Yeah, I know. Guys, if you're late, I apologize. Just tell them to call me. Sorry. All right.
Okay.
I'm right across from here, so that's not a problem.
Oh, good. I gotta.
I'm literally in Reynolds now. It's like literally